Introduction to Python. You may have heard that old adage, we have to learn to crawl before we can walk. Similarly, we need to install and configure Python on our computers before we can begin developing Python programs. Therefore, our first order of business is to understand the various implementations of the reference CPython installer. We're going to understand how to install Python, or verify its installation as the case may be, on Linux, Mac, and Windows systems. After we have Python up and running, I'm then going to introduce you to the Integrated Development Environment, or IDE, that ships with the reference version of Python. That's called IDLE. I'm going to make a good case that it's important for us to master this tool as we gain our sea legs, so to speak, in understanding and applying the Python language. Third, we're going to use a variety of methods for running Python programs that we create. We're actually going to work with the Python interpreter directly in so-called interactive mode, and we'll also save out Python script files and run them from the operating system. There's a lot to do in this nugget. Without any further ado, let's get to work. What I've been told, and what I like to tell people with regard to Python 3's minimum system requirements, is that as long as you have enough processor power, free hard disk space, and RAM to support your host operating system, whether that's Mac OS X, Linux, or Windows, then you're perfectly fine on installing Python. Python's an extremely accommodating application for sure. Now then, specifically, with Mac OS X and Linux, Python should already be installed on those operating systems. The easiest way to find out is to open a terminal prompt, also known in the Windows world as a command prompt window, and simply type Python space -V. In the upcoming demos, I'm going to show you some of these command line parameters that we can throw at the Python executable in order to customize its running. Uppercase B simply returns the currently installed version of Python. On Linux and Mac OS X, if you've installed Python 2, which is the default build that you'll find on any version of Mac OS X, for instance, Leopard, Snow Leopard, Panther, Tiger, etc. And on Linux, same thing. However, once you go to Python 3, and of course Python 2 and Python 3 can be installed side by side, and especially on Mac and Linux machines, should be installed side by side. More on that later. You can type Python 3 -V just to verify again that version, although with Python 3 it's pretty obvious, isn't it? Now, political things in technology really kind of bother me. For instance, in an earlier nugget, I think I mentioned very briefly how much I wanted the Apple iPad. Well, guess what? On opening day, there I was at my local Best Buy in Nashville, Tennessee, and within 5 minutes, there was hardly any line when the store first opened. I had my iPad. And believe me, this is the best tech gadget I've ever had in my life, even better than the iPhone. But there's political things that go on that really bother me about it. There's political machinations between Apple and Microsoft and Apple and Adobe such that the iPad and the iPhone, as of this recording in April 2010, don't support, say, Microsoft Silverlight or Adobe Flash. Well, similarly, you'll notice that Mac OS X and Linux Unix almost always will have Python 2 installed with the operating system. Unfortunately, Windows and Microsoft being a closed source proprietary operating system and software company, you're going to find that extremely useful scripting environments like Python are not installed. Of course, you'll have access to Microsoft scripting utilities like VBScript and PowerShell, but we won't have Python. Let me get off my soapbox. I think I've made some good points in information technology, but back to the subject at hand. You can easily download the Windows Python installers. These are in binary format, which means that the source code has already been compiled to an executable format, just zeros and ones. In particular, the Python group issues the Windows binary installers as Microsoft Installer or .msi packages. These convey some really nice benefits when you're installing, and uninstallation is a lot cleaner than it was in previous versions of the Microsoft Windows installer. Now you can get 64 or 32-bit versions of Python from the python.org website. So you'll obviously, if you're running a 64-bit capable processor, you'll want to install the 64-bit version of Python. Likewise, if you're only on a 32-bit system, you'll need to make sure to get the x86 version. On Macs, although you have Python 2 built into the operating system, for the purpose of this training, and if you're learning Python for the first time, as I've said before, I would suggest that you start with version 3. You can download a macOS 10 disk image of the Python 3 installer. They use the traditional Apple disk image format, .dmg, or if you're a Linux Unix person, you can either go with a pre-done, pre-compiled package. We'll talk about that in more detail in just a moment. Or if you're one of those traditional configure, make, install folks, you can download the tarball and extract and install the Python from source. The .tgz or tar.bz2 are two formats that may look cryptic to those of you who don't have expertise yet with Linux. Basically, you're using two utilities here. It's pretty traditional in the Linux world. Tar is used to create a single archive out of a whole bunch of different separate files, and then either gzip or bzip provide various levels of compression to that tar archive. That's similar to how we have in the Windows world. You can use WinRAR to create RAR archives that are both just a single archive as well as heavily compressed, or more commonly the zip format, or if you've used Stuffit in the Mac environment, there's the .sit. Same thing. Next, we're going to take a look at the high-level overview details of installing the Python environment on Windows, Mac OS X, and Linux. And what I'm showing you here is a representative screenshot from that .msi Microsoft installer for Windows. And what you're seeing here is a nice feature of the Microsoft installer where you can do a custom install and pick and choose which components you want to install. Now, I would recommend that you install everything, that you make sure that all components are selected. You'll notice down below that the disk footprint for installing everything is remarkably small. It's typically under 100 megabytes. So you're certainly not doing yourself any harm from a disk usage standpoint by installing everything. Now, what are these components? You'll notice that besides the core Python files and the Python executables, you have some options. There's register extensions. The reason why this is important is that in Windows you can then double left click a .py or a pyc compiled Python script file and automatically create an association between those files and Python. Okay? TCL and TK gives you what's called the tkinter toolkit. This you can just look at as your GUI platform. We're going to learn more about graphical user interface development later in the course. tkinter is a pretty standard one, and as a matter of fact, the Python reference IDE, idle, is itself a tkinter application. So you won't be able to run idle unless you install the TCL TK extensions. If you install the documentation, you'll get a compiled HTML. If you've ever used the .chm help files before in Windows, you get one of those. It's a really great reference, especially if you don't have access to the web at a given point in time. Utility scripts, the main centerpiece there is that 2 to 3 utility that I talked about earlier in the course. This is a conversion tool where you can feed in Python 2.x code and come out with 3.1 code. And then finally, there's a test suite that can be helpful for debugging purposes or internal testing. The earliest version of Mac OS X you're going to want to try installing Python 3 on is Mac OS 10.3. Chances are you're running at least 10.4, if not Snow Leopard, which is the current version, 10.6, of the Mac OS X operating system as of this recording in spring 2010. And here we're seeing the analogous custom install screen on Mac. You'll notice that the options here are named a little bit differently. Instead of tkinter, it says GUI applications. Of course, we're going to want to install that. Notice that the Python framework cannot be deselected. Unix command line tools, that's important for you to keep selected so you can, for instance, run Python 3 at a terminal shell in Mac to launch the Python interpreter directly. There's our link to install Python documentation. The shell profile updater option is also crucially important in my opinion. That will automatically set the appropriate environment variables such that Python can be found in your user search path. And then finally, this is a potential gotcha that I want to make you aware of, the Fix System Python. Please do not select this option unless you have an extremely compelling reason to do so. Here's the deal. Remember that Mac OS X does have Python 2 installed by default. Accordingly, you have some Mac OS X routines that rely upon that Python environment. If you choose Fix System Python, then that's going to scrub your Mac system and change all references to Python 2.x to Python 3.x, whatever version you're installing. Therefore, to avoid those compatibility issues, make sure you don't choose fixed system Python. In other words, you want to have Python 2.x and 3.x running side by side. There's no problem with that in a Mac environment. Actually, there's no problem with that in any operating system environment. And now for something completely different, to bring up yet another Monty Python reference. That's neither the first nor the last one. It just goes with the territory. Let's look at the details for Linux installation. Now, of course, as I said, Python 2.x is typically going to be installed in your Linux distribution, but if you want to install version 3 as well, you have plenty of options. If you're not a compile from source person, you can certainly grab a pre-done binary package. The two main application package formats that, if you're understanding me so far, you've probably used one or both of these, are the Red Hat Package Manager or RPM packages that are used not only with Red Hat and Fedora and that category of Linux distributions, but you can use RPM in just about any Linux distro, actually. The other popular one is the Debian format, the .deb. This is the package format that's used by default in Ubuntu Linux, which happens to be my favorite distribution, at least for daily use. Now, how do you handle these? You can install RPM or Debs directly using command line tools, or you can use graphical package managers. In a Red Hat environment, there's Yum. In an Ubuntu environment, for instance, there's the Advanced Packaging Tool, or APT. You can actually query your software repositories with apt-get and install Python 3 and or idle very, very quickly from a terminal shell window. Or if you want to use a graphical utility, at least Ubuntu uses the Synaptics package management system. A lot of flexibility here with Linux. If you have experience using Linux, then you're all familiar with that flexibility. The main reason, or I should say main reasons in my experience, why folks like to compile their software from the source code is, number one, just because they're geeks and they're used to doing it that way. And just as commonly, number two, is that you typically have much greater control over the installation process when you're starting from those underlying source files. You'll never see this in Microsoft, of course, because Microsoft is a proprietary closed shop. On the other hand, Python and the Python Software Foundation, I'm sure, is proud of this. Python is official open source software. You can look right down to the module and code level to see what goes into Python. And at least with the reference version that we're using, you'll recall that the underlying development language is C. So anyway, you would run this configure, make, install process in order to fully customize your Python installation. There's certainly less to customize here than there would be, for instance, if you were to compile, say, the MySQL database from source. But it's still an option, and I'm actually going to run this process to show you what it looks like if you've never seen it in the upcoming demo. The bottom of this whiteboard, you see a screen capture from the Ubuntu Software Manager, where just with a few clicks of the mouse, we can install Python 3 and or idle. Linux software installation has come such a long way in the last 10-12 years or so. It's so much easier than it used to be. Environment variables. After you install Python, you may or may not need to do a little bit further work to customize the Python environment. Certainly, though, as you gain expertise with Python and begin using this in real-life software development projects with team members, you may definitely be required to change one or more of these environment variables. First of all, for those of you who are not familiar with these bad boys, what are environment variables? These are defined formally as dynamic named values that affect how a running process behaves. This is a really succinct, good definition, actually. Dynamic because environment variables can typically be changed on the fly. We can set an environment variable to be permanent. We can set an environment variable to be permanent or temporary on a user-by-user basis, say only for our user account. We can also set environment variables that are global to the machine, such that any user who logs onto that computer receives those settings. Now, there are a lot of environment variables used in Mac OS, Windows, and Linux. We're constraining our discussion to the key variables that are used with Python. First, we have an operating system variable called path. This is also called the search path. It works like this. Let's say we're in a Windows environment and we've installed Python 3 in the Python 31 directory on our C drive. We then open up a command prompt, and let's say the command prompt has us in C users Tim desktop. In other words, a location that's not the directory that contains the Python executable. If we were to type Python and try to log in to interactive mode to work with the interpreter, if we don't have this path, C:\Python31, in our search path, then it's not going to work. Bottom line, the search path is a collection of directory paths that the operating system will use to look for executable code, such that you can be anywhere in the file system and instantiate, in this case, Python from, like I said, wherever you are. It's a really convenient environment variable to set. Depending upon how you've installed Python, you may find that your path has automatically been updated appropriately. I just wanted to make you aware of this. So whereas path is an OS or an operating system level environment variable, there are some ones that are created or you'll create specifically for Python's use, the Python virtual machine. Of these three, I'd say the most important one is Python path. We use this quite a bit to manage import files. Now we want to not run before we're actually walking, but an import is simply where you take a Python module, in other words, a separate .py file that contains additional functionality, formally called attributes. You can also look at these as functions and classes that you want to add into your project. It's a really great way to modularize and reuse code, so that in our top level py file, we would create or write an import statement to bring in that external module. Python path is important because we don't have to qualify where this module that we're importing is coming from. We would just make sure that if the module is located in a directory that's not in our current Python path, we would edit the Python path to include that folder such that the Python virtual machine simply knows when you run import foo, it knows where to find foo.py, and then you'll have that code available to you in your script file. More on that much later. This is just the barest of introductions. Python startup, in my experience, isn't used all that much. This is used to set up an initial working environment on your machine. You can consider Python startup to be kind of an autoexec.bat file if you're familiar with that in Windows. This is going to be a sequence of one or more Python statements that you want to execute prior to the launch or as the interpreter is launching. Finally, we have TCL library and TK library. These are Python variables that point to the tkinter GUI variables. Lots of different ways to set environment variables. Specifically, you can go to the command line on Linux machines and use export to set, for instance, a Python path. You want to be careful when you're using command line tools to manage environment variables. For instance, let's say we wanted to add the path user local lib py3 to our Python path. So this would be a folder or a directory on our Linux or Mac system that was going to contain some modules that say we downloaded and we want to be transparently available in our Python projects. Well, if I just ran this export command, I'm going to overwrite my existing Python path. So typically what you'll do when you're appending to a path is in Linux you'll say import Python path equals, and what we'll do is simply write export Python path equals, and then we'll pass in the $path environment variable colon, and then we can add our new directory. Same thing works in Windows. From a command line in Windows, we can use set Python path equals, and then here we reference environment variables generically with percents. So we would say %path %, or in this case, Python path for each of these, and you'd separate with a semicolon. So there's just some minor formatting differences. In Windows, actually, you can use the system control panel to manage environment variables. It's a heck of a lot easier than horsing around with these command line options where you can inadvertently overwrite your existing paths. It's time for our first demo. In this demonstration, I'm going to show you how to install Python 3 from source on an Ubuntu Linux machine. Then we're going to run through a binary installation on Windows, and then we'll work a little bit with environment variables so you can get a better feel for how those work with Python. Here we are on LinNugget 1. This is an Ubuntu 9.10 box. I'm going to open up a terminal shell here. And before we get to installing Python 3, let's verify that we have Python 2.x installed. And we can do that by running Python with the uppercase V. Remember, the case is important here for these parameters. Uppercase V. We see that the latest and greatest edition of Ubuntu comes with Python 2.6.4. and is located in user bin, and then there's the Python executable. No big surprise. I'm now going to transition over to my desktop and display the contents of my Python 3.1.2 tarball that I downloaded from www.python.org. We'll then minimize, and I want to take you out onto the web so we can see where to download this tarball in the first place, at www.python.org/download. And you notice that the current production versions as of this recording are 2.6.5 and 3.1.2, and we're learning 3 with a nod to Python 2. But an important point that should be mentioned, I did mention it earlier in the training, is that at least at this point, most existing or more existing third-party software is compatible with Python 2 than Python 3. So let's come right down to Python 3.1.2. You'll notice we can grab the x86 MSI for Windows, that's the 32-bit, then we have the x64, it's actually both, but primarily we'll do this for 64-bit machines. There's our Mac OS X installer DMG file, and then finally you can download the tarball. This is the source code for Python 3.1.2 either as just a regular compressed tarball with gzip, or you can get a bzipped, which is simply more highly compressed. Same exact contents, it's just a difference in compression ratio. So I've grabbed one of those tarballs, and you can use tar and gzip if you want to do this stuff from the command line, but most windowing Linux's system, Ubuntu certainly included, will allow you to extract the files upon download. So to do this from source, to install Python from source, traditionally what you do is you run the configure script and create what's called a makefile. Because this path, home desktop Python 3.1.2, is not in my current search path environment variable. You might recall or might not that in Linux you specify // that tells Ubuntu to look in the current directory, and we run configure. Now the configure script is where you can customize exactly how you want your installer, your binary installer, what you want it to look like. I'm just going to do a plain vanilla configure. What happens during the configure step, besides getting ready to create your binary installer, but it's looking at your system, reading all your system's environment variables, and it's looking to test for dependencies. Many years ago, dependencies were a huge stumbling block in compiling software from source. You'd have to keep rerunning the configure script over and over and over as you discovered dependency modules that weren't installed, and you had to go and install them. In this system, this latest and greatest version of Ubuntu, I think we're pretty fine. We have all of our dependency modules already installed. Assuming the configure script completes properly, we can then use the make utility, and I'm going to use sudo here to make sure I'm elevating my credentials. I'll put in my password for trainer and then go ahead. And what the make step does is it takes the results of your configure script and any changes you've made to that script to customize the installation, and the C compiler in Linux here is now building a binary installer that will then install in step 3. Alrighty then, once the make happens, the final step, and again I'm going to sudo this just to be safe, we run make install to run the binary installer, unpack the files to their destination. Of course, changing the installation directory is one of many things that you can do by editing the configure script directly. We don't need to worry about it in this case though. Process finished. Let's clear the screen. And if we run Python 3 with the v/, we can see our specific version of Python is 3.1.2. We run which on Python 3. We see that the default installation directory is user local bin, and then to launch the tool, we can simply run Python 3 to log directly into the interpreter. The fact that I was able to do this from a directory other than user local bin tells me that the path environment variable has already been set up for us in that default configure script. Control-D is a keyboard shortcut that you should be well familiar with on Mac and Linux machines. Control-D is going to take you out of the interpreter and out back into your operating system shell prompt. Now let's transition over to Windows, and I'll show you how to do a binary installation on that platform. Now we're on WinNugget. This is a Windows 7 desktop computer, and I've already visited python.org and I've downloaded the appropriate binary installer. I want you to know, in passing, that although we're working with CPython, the reference implementation that's given to us courtesy of the Python Software Foundation, a company called ActiveState, who is a member of said foundation, they have their own build of Python. The current one that they have is 2.6, but it's called ActivePython, and it's simply another distribution of Python that you might see in the literature. We may talk about this a little bit in the future. It has some extras thrown in that the reference build doesn't, especially for Windows developers. I just wanted to make you aware of that in passing. For our case though, here's our Python 3.1.2 Microsoft installer package. You see it weighs in a little under 14 megabytes, very small. We'll double click this guy to kick off our installer. The first question we're asked by the Python setup installer is, are we installing this for all users or just for the local user? Well, I'm going to choose all users. The default installation location is CPython31. I would recommend you keep that or a similarly really short path just for convenience. Here's where we get to our customize screen as I showed you in the whiteboard portion. We're going to leave all of this enabled and just let her cook. It couldn't be simpler, really. Alrighty then, it's finished. So let's click Finish, and then we'll open up Start and All Programs to take a look at what's going on. You'll notice that we have a new item in our Start menu, Python 3.1, and you'll see we have Idle, Module Docs, and Python Command Line. Those are our three options. We're going to become very familiar with those as we go along. But first though, let's address the issue of environment variables. We're not going to worry about the Python specific ones now. We're going to deal with those as we move along in the course and get deeper and deeper. But certainly we're going to want to be concerned with the path environment variable, the operating system one. As you see, I'm opening an elevated command prompt here, and it defaults me to C Windows System 32. Let me go to the root of drive C and type Python. It tells us that it's not recognized as a command. That's simply because the file's not in our search path. Now, while we can open a command prompt, or keep that one open actually, and use the set command to adjust that search path, in Windows I think it's much easier to, in 7, we can open up Start, right-click the computer item, come down to Properties. This is simply a shortcut to going into Control Panel and launching the System Control Panel directly. And in the task area, we'll select Advanced System Settings, and on the Advanced page of the System Properties Control Panel, we'll select Environment Variables. And under System Variables, this, by the way, is where you'll want to choose New to create your Python path, Python startup, etc. But if you just want to add to your path, your executable program file search path, we can select Path from the Variables list, choose Edit, go to the end of the list, throw in a semicolon, and then add the directory to your Python executable to this list. In my case, it's C Python31. So we'll OK out of this, restart, and then we'll give it a try. Now that we've returned from our restart, let's open an elevated command prompt again. We'll use Python V to give us the version. That worked okay. Then let's run Python with no arguments, and sure enough, we're in interactive mode. Now, Control D does not work in Windows like it does in Linux. So you'll remember to exit interactive mode. Control D is what we use in Linux. In Windows, if you type exit just to try, you'll notice we can make a call using the built-in function exit, or more commonly, Control Z plus return. So just remember the appropriate command for your operating system. What is an IDE? IDE stands for Integrated Development Environment, and an IDE is actually a piece of software that does a lot of really nice things in support of you, the application developer. An IDE is going to principally be a source code editor, kind of analogous to how you would use, say, Microsoft Excel if you were going to do some charts, graphs, and number crunching. It's a really nice organized way to keep especially multi-file projects organized. Most IDEs worth their salt not only will allow you to interact with source code directly, but will also go above and beyond by making it easier than using, say, a Notepad or TextMate or Vim or Emacs, just a plain text editor. An IDE will typically give you features like code completion. So as you're typing in statements and methods and functions, you'll find that the IDE suggests things to you. This can help the beginner begin to identify how syntax works, and then as you gain intermediate proficiency and then expertise with Python, you'll find that it just improves your development speed because you can type part of a function name or part of a method, let's say, and then hit Enter or Tab, and Python will complete the rest of that statement for you. That can be helpful, at least in my personal experience, to avoid the human error of fat fingering and making keyboard errors. Now, Python, as you know, is meant to be eminently readable. So code folding is not as important in Python as it is in other languages like the C languages. Code folding refers to being able to collapse your statement blocks. So instead of looking at a source code file with all of your procedures and routines expanded, code folding enables you to fold those up and then selectively expand code blocks to make the code easier to understand. Simple as that. An IDE will also typically offer syntax highlighting. Now for me this is irrelevant because I'm very colorblind, but so long as you have proper color perception, you can then figure out what your variables are, what your functions are, what your methods are, and all this because these different elements will be highlighted in a user configurable color. An IDE is also generally going to allow you to directly run your code in testing. For a compiled language, like the C languages, the compiler will actually do a quick build of your code and then present you with the interface, the actual runtime environment. In Python, remember that we're dealing with interpreted code, so this step is going to be much faster. But it's nice because you can make tweaks to your code and then immediately see the result. Many IDEs also have builders and automated packagers included in them. Visual Studio from Microsoft is a good example. This makes it easier not only to finally compile your code if you're using a compiled language that is, but also develop final runtimes that you would then pass along and get ready to distribute to your users. When we're developing software, debugging is just a necessary evil. It's part of the process. We can look at it positively, though, as a learning experience, certainly. IDEs typically give us a much bigger leg up on debugging problems in our code by allowing us to do things like setting breakpoints, where you can flag your code at a certain point, and then when you run the compile or interpret step to run the code and test it, you can stop at that breakpoint or just simply see what the value of particular variables are at times in your code. It's really useful, and we'll pick this up later in the course. So I hope I've sold you on how useful an IDE can be to software development. Now you'll find that IDEs are somewhat controversial in the Python community in particular. I think some experts feel that an IDE abstracts too much of the underlying what's going on in your Python program from the programmer. Similarly to how I remember when I went through school and learned math, calculators were introduced very late in the game. So we had to do just standard pen and paper number crunching. And I think nowadays, in fact I know nowadays, the majority of secondary schools are using calculators as a rule. So an old stodgy person like myself would wonder, is the calculator abstracting too much of the mathematics and making it more difficult for the student to understand the building blocks? Well, we're going to leave that argument for another day. I find that at least the built-in IDE that ships with CPython, it's called IDLE, provides the best of both worlds. I think it gives us a great degree of transparency. It is a pretty bare-bones IDE. It doesn't have code completion. It doesn't have code folding. In fact, there's not even a provision for adding line numbers to the code right on your screen. There is syntax highlighting. There is interaction with the interpreter. You can run, test, run, test. There's no builder, and there is a rudimentary debugger. So IDLE does have quite a few of these features. You certainly can't beat the price and the convenience because it ships with Python. But at the same time, like I said, I believe that IDLE gives transparency, especially when you're working in the interpreter directly, in the interactive mode, where you're sending statements directly to the interpreter. It can be an extremely useful way to build your skills in Python, and we're going to be using the interactive mode a lot in this course. As previously discussed, IDLE is a GUI application. It relies upon the tkinter framework. Because of that, and this is a gotcha, you may find some compatibility issues. We'll cover this, of course, later in the course when we do graphical user interfaces. If you use the tkinter building blocks to create your own GUI application and then try to run that in IDLE, sometimes you may wind up with problems. Therefore, the best practice is if you're using tkinter as your GUI framework, you may want to run those programs in your testing outside of IDLE. Now, some of the stodgy folks, professional coders or whoever really, want to bypass the IDE and that's perfectly okay. I'm not here to advocate one way or the other. What I like to present to you are options, and then you try them both and decide which works better for you. Now, I shouldn't have actually bracketed both of these items, because really the bare bones way to go, you don't need an IDE strictly speaking. You can use just an ordinary text editor like Notepad or WordPad in Windows, Vim or Emacs in Linux, and also we can use that in Mac or even install these in Windows for that matter. Some folks really like these really bare-bone tools. Certainly I would recommend against, in the strongest terms, you using something like Microsoft Word for your source code, because of course Word adds all sorts of other gobbledygook in the file. It's not just your code. But like I said, that's another way to work. Do your source code in a text editor and then just call Python directly from a terminal shell. If you're interested in alternate IDEs, we're going to be covering these in a great degree of depth in the tail end of this course. But just to wet your whistle now, there's at least one really dynamite open source IDE. It's from Sun Microsystems and it's called NetBeans. Actually, there's another one that's in the open source space called Eclipse. And both of these are multi-language IDEs. In other words, although Sun Microsystems creates and maintains Java, therefore NetBeans, you can tell right from the name, is principally intended for Java development. You can plug in Python support and use NetBeans as a really rich and robust IDE for your Python projects. Similarly, Eclipse is the same thing. It'll function as an IDE for a variety of languages, Python certainly included. If you're willing to spend some extra money to get some premium features, the two main ones that I've used and would recommend are ActiveState Komodo IDE and WingWare Wing IDE. More on those later though. I'm just trying to wet your whistle, as I said, get you interested. Alright, so at this point we've covered how to install Python on a variety of OS platforms. We've done some work with setting environment variables. We then discussed idle a little bit. Incidentally, I wrote this on the whiteboard, the previous whiteboard, but I forgot to actually tell you. Remember how Python has its name derived from Monty Python's Flying Circus? IDLE is actually not an acronym. It's a reference to Eric Idle, a member of, you guessed it, Monty Python. So the humor continues. The humor continues. So that brings us to how do we actually run Python programs. I mentioned that, especially in the hacking, ethical hacking, and penetration testing community, Python scripts are used a lot to automate some really cool tasks there. Python's also big in systems administration. You can automate your work. Simple as that. So therefore, you may download .py files from the web, and you may want to maybe edit them a little bit, and then of course run them to do the work that you need them to do. What are the ways that we run those programs? Well, you can use the interactive prompt, and this is where you, for instance, if you have Python already installed, you would open up a command prompt or a terminal shell, type Python, and you'll wind up with the Python prompt, and you're interacting directly with the Python interpreter. Now you can do that from in the OS, or we can pop open idle and work with the interactive prompt in a GUI environment. That works fine. However, for actually running Python programs and getting them to do work, you'll probably want to go this way, the system command line, where again, from an OS shell, we call the Python executable, space, and then we call the script file. We may need to qualify the path of that script, of course, so that Python knows where to find it, but that's how you'd actually run a typical Python application. The interactive prompt, in my experience, is chiefly for development, testing, and learning. Finally, as long as we have our .py and or .pyc files associated with Python on our machine, we can use icon clicks. And what that simply means is locating the py file in the file system and double left clicking it with your mouse to launch it. In our second demo, I'm going to introduce you to the idle environment. We're going to become much more familiar with it as we go along. This is our initial introduction, however, and then we're going to work with running Python programs. In this second demonstration, we're going to look at the idle IDE as well as how to run Python programs. Everything you see here is going to be directly portable to Mac OS and Linux environment. I'm just using Windows here arbitrarily. To find idle, you'll recall once we've done our installation, we can open the Python 3.1 folder in the Start menu and choose idle Python GUI from the list. So after much anticipation, here is idle, also called the Python shell. This TK here is a reference to TK-Inter, the underlying GUI framework for this tool. cool. Now, as far as IDEs go, this is pretty bare bones, which I think is a good thing. If you've used Microsoft Visual Studio, for instance, you've probably been overwhelmed by all the options that are there. Python Shell is pretty elegant. You'll notice that when we're in interactive mode, we can see that with the 3 chevrons, or the 3 closing angle brackets. That means we're interacting directly with the interpreter. Let's walk through the menu options quickly. In the File menu, we can create a new Python script file, we can open a script file, we can open a module, more on those later, and just your traditional save, print, close. I'd like to draw your attention very briefly to this Path Browser utility. What this does is run an attribute from the sys built-in module that comes with Python by default and runs sys.path, which returns the default Python path. You'll recall that the Python path is the environment variable that Python uses to look for module files. So more on that later, I just wanted to show it to you now. In Edit, you have your traditional undo, redo, cut, copy, paste, find, etc. In Shell, this is useful if periodically you want to restart the shell and kind of reset your interactive mode environment. There's a fairly simple but straightforward debug menu, and more on that later. Options is where we really want to head. But before we do that, you'll see in Windows we can adjust the zoom height, we can toggle among multiple windows if we have multiple windows up, and then we can access the Python documentation, the help, or look at the About screen. The Python docs option is useful because in Windows at least, it gives us the CHM version of that documentation, which I really like. You can look at the contents tree, you can drill in and do a search of that documentation, and even set favorite pages. Really good stuff there. Now, we want to set up our idle environment here. We can go to Options, Configure Idle, and we can change our base editor font. I like Courier New. We can make the text bigger or much bigger. I'm going to tend to increase the size of the font for readability for you. Indentation width, I would recommend strongly you keep this at 4 spaces. We're going to make sure that this training is fully in accordance with Python style best practices. More on what indentation does in a future nugget. Remember I mentioned that idle gives us some rudimentary syntax highlighting, so you notice that function declarations are coded in one color, strings are in another, errors, etc. You can customize those if you want to. Keyboard shortcuts or key bindings, you can view those or modify those there. And then general, do you want to open to an edit window or the shell window? You see shell is the default. Autosave, which we'll see in just a minute. We can load additional help sources. So pretty straightforward, no question about it. We're going to finish this nugget with how to run a Python program. Assuming we've downloaded one, I'm actually going to create a simple Python file right now by going to File, New Window. And this opens another, window that we can now shift between the Python shell itself, the interpreter, and this file. And before I do anything else, I'm going to save it. And on the root of C, I'll create a new folder called Projects, and I'm going to call this file hello.py. Now, you're probably accustomed in Windows not to add the extension to the file, especially because Save as Type is already listed appropriately with this filter. However, you need to add the py extension. Please don't forget that. You're going to ruin the file association if you don't. Of course, you can always correct it afterwards by manually renaming the file, but this is a common newcomer mistake. Make sure to add the extension when you're doing your file. This is going to be an extremely simple file. It's just going to contain one statement, the print function. What would an introductory program be without the requisite Hello World example? This has been done since the early 70s as a way to demonstrate the very basic syntax of a programming language. So I'm going to save my file, and you can actually run the script directly. This is way 1 or method 1 for running a program by opening up the Run menu in Idle and choosing Run Module. Alternatively, you can use F5. And this switches us over to the Python shell, and that command, all it simply does is echo or print a string, and of course I used Hello World. Very easy. Other ways to run the code, we can use icon clicks. We navigate to the projects folder. You'll see that hello.py has a little snake on it. That tells us that the association is correct. We can double left click it, and you might be surprised by what you saw. You saw just a flash, didn't you? That's one of the things that Windows does that you'll simply need to handle in your code. Now in this case, we didn't put in a pause of any kind. So it just simply opens a command interface window, a command prompt window, displays the hello world text, and then goes away. There are lots of things we can do to keep that window open, and we'll be working with those in the future. Final thing we're going to do is run the command using the Python executable. All we have to do here is type Python space and then a path to the file. Of course, we could just do python hello.py if we were in the projects folder. Otherwise, we have to provide the fully qualified path. And there it is, hello world. Introduction to Python review. In this nugget, we looked at how to install Python on your system. Technically, we looked at verifying whether Python is installed, and then I showed you how to install a new version of Python under Linux, Mac, and Windows. Therefore, your operating system bases should be covered. After we installed, we understood how to customize the Python environment by using environment variables. I then gave you an initial introduction to the idle integrated development environment, and we set that or framed that in a larger context of those two development modalities. That is to say, using the IDE or simply using text editor and the Python executable directly. Both equivalent methods. Choose which one you find easier. And then finally we looked at just a very simple question of how do we run a Python program that we may have been given or we may have downloaded from the web. I hope that this has been informative for you, and I'd like to thank you for viewing.